Hi, I'm Pat from VMOD 3D Library. Today I'm going to show you how to apply VMOD's textures in Cinema 4D Octane Render. First, let's take a look at the final render. You can achieve a photorealistic look like this by applying VMOD's textures in Cinema 4D, along with creating basic nodes and adjusting parameters. Let's get started. Today, we'll be using this fabric. You can get this item with free credits if you sign up for VMOD 3D Library now. Today I'll choose the high-resolution texture. Let's take a look at the texture list. Here you can see the textures for rendering. There are 7 PBR maps and mask maps as well. But I'll only use the PBR maps today. We'll talk about the mask maps later in another video. This fabric is a non-metallic one, so I'm going to utilize base, normal, displacement, roughness, and ambient occlusion map, except for the metallic map. Okay, I loaded a Cinema 4D project file for rendering. In this tutorial, I have set up the lighting using an HDRI light with normal contrast and a 3-point light. Here's how we're going to set up the Octane render settings. Although the max sample count may be insufficient, but I'll proceed with rendering using the denoise function. Alright, now that we're done with render settings, let's create an Octane material. Click on Create, Extensions, C4D Octane, and Octane Material to create a material. You can simply drag and drop to apply the created Octane material to an object. If you open the Octane Live Viewer with the Octane Node Editor, you can observe the real-time rendering. You can also resize the window according to your preference. I'll set it like this. Import the downloaded texture maps by simply dragging and dropping them. Next, let's move on to configuring the Octane Material settings. Click on Octane Material, then select Basic. Change the material type from diffuse to universal and set the BRDF model to GGX. By changing the material type to universal, you can enable a more versatile and creative presentation of the material. Feel free to adjust it according to your specific needs and creative preferences. Now, let's start rendering and connect the texture maps one by one. Connect the base map to the albedo port, and then roughness, normal, and opacity. However, the displacement map can't be connected directly to the displacement port. So, we'll create a displacement node by pressing the Tab key on the keyboard and connect it to the displacement map. Then, connect the displacement node to the displacement port. Now that we have all maps connected except for the Ambient Occlusion Map, let's adjust the parameters in each of the connected maps. First, I'll start with the displacement. The default height value is set to 10 centimeters. Looking at the render window, 10 centimeters seems a bit too high, so let's find a value that works for us. I think it looks nice when it's set to 2.1 centimeters. Now, let's increase the level of detail value on the displacement. I usually prefer using a 4K size for my settings, and that's what I'll be using today. I changed the level of detail to 4K, and now you can see it looks more detailed and realistic. Second, let's adjust the normal. I think it looks good enough, but I want to make the details stronger. So, I'll adjust the power value. Click on the normal map and put 1.31 to power to bring out more details than before. Let's move on to the roughness map to depict a rougher material. Since the roughness map needs to be set by grayscale, you should always create an Octane gradient node to make necessary adjustments. Add an Octane gradient node by pressing the Tab key on your keyboard. And then, connect the input to the roughness map and the output to the roughness port of material. Click on the Octane gradient node and right-click to turn it into solo mode so we can adjust the roughness. I'll replace the black parts with a lighter shade and increase the contrast by closing the gaps in the graph. By clicking on the Octane gradient node again and right-clicking to disable the solo mode, we can observe how it looks with the modified roughness map. Now, it looks rougher overall. Next, I'll use the base map and Ambient Occlusion Map together to create a more realistic map. Press the Tab key to create a multiply node. Connect the base map to Texture 1 input, and connect the Ambient Occlusion Map to Texture 2 input. Reconnect the output of Multiply to the albedo port. Let's see. I think the color looks too dark. Let's modify the Ambient Occlusion Map to make adjustments to both color and details together. Let's apply a similar modification as we did with the roughness map by adding an Octane gradient node. Press Tab between the Ambient Occlusion Map and Multiply to create an Octane gradient node. Let's slightly brighten up the dark areas and add a touch of contrast to make it more realistic. When modifying the ambient occlusion, you can do it in the solo mode that I used before, but today I'll adjust the values directly in the render window. After adjusting the ambient occlusion map with the Octane gradient node, now it looks more detailed and realistic. Okay, we're almost finished with the texture details. But I think the texture scale looks too large. Click on the base map and then click UV Transform to create a transform node. All maps should always be the same size. So, let's connect this transform node to other transform ports as well. After connecting to all the maps, I'll adjust the XYZ scale equally on the transform node to achieve the scale I want. I think this looks great. Now, we illustrated the material by using texture maps and a node graph, and adjusted the scale by the transform node. I think it looks photorealistic enough, but I'll make some additional adjustments to give it more of a sheen and fuzziness to the fabric. There's a sheen layer if you look at the Octane material. Click on Sheen layer, and put 1 to sheen value. Now it looks different than before. Sheen layer adds a sheen to the material, particularly suited for velvet and satin fabrics. Let's make further adjustments to the sheen layer's roughness value with observing the rendering results. Now it looks fuzzy enough, but I think it still doesn't look like an actual fabric. This is because the sheen layer color is white, and it doesn't go well with today's fabric. Let's change the color to violet that matches to the base color map, to achieve a more natural appearance. I'll create the RGB spectrum node here. Create the RGB spectrum node, and then connect it to sheen port by clicking the toggle button under the sheen layer. Then, adjust the value to get a color similar to the base color and progress towards the desired look. I think it looks great now. So, this is how we apply PBR maps in Cinema 4D Octane. All parameter values are optimized for this specific fabric, so you should adjust the values differently when working with other fabrics.